Well, let's continue solving polynomial inequalities. And so in our first inequality here, we've got 2x squared minus 10x is less than or equal to 2x minus 16. Well, the first thing I want to do is get everything on one side of the equation, set it equal to 0. Remember, we're going to solve it initially like it's an equality. And so as we do that, then I would have 2x squared. Then I've got negative 2x, but I'm going to move that, negative 10x, but I'm going to move that negative 2x over, and it's going to become a negative as well. So then it's going to be negative 12x. And then as I move the negative 16 across, it's going to become positive, and so I got plus 16, and we're going to say that's equal to 0. Okay, well now I got to factor this thing. So I'm going to draw two sets of parentheses since it's a quadratic. And I've got a 2x squared. It means I'm going to have 2x on one side and an x on the other in the other parentheses. My constant 16 is positive, but my middle term is negative, meaning I got to have a negative inside my parentheses. That's the only way I can end up with a positive by multiplying and adding a negative by adding. And then I got to figure out, I need two numbers that are going to multiply to 16 and add to negative 12 with one of my coefficients of my x factors being 2. And I'm going to try 4 and 4. I guess I ought to put equal to 0 there. Let's see, 2x squared, negative 8x, negative 4x, negative 8x, negative 4x, negative 12x, and then negative 4 times negative 4, positive 16. Okay, that looks good. Now I'm going to set each factor equal to 0. So I got 2x minus 4 equals 0. Add 4 to both sides. I got 2x equals 4. Divide by 2, and x is equal to 2. So that's going to be where one of my intervals start. And then I've got x minus 4 equals 0, and we're just going to add 4 to both sides. And so I think I got a solution set where I've got to test intervals at 2 and 4. So let's draw a number line. Let's say this is 2, this is 4. All right, let's see. I want to go back to my original equation. Well, over here on the left side of this interval, I could use 0 as my test point. So if I put 0 in for x squared, 2 times 0 is 0. Or 0 squared is 0. 2 times 0 is 0. And negative 10 times 0 is 0. All right. And then I've got, substitute in 0 for x, and it's 2x. Well, 2 times 0 is 0. And then I got negative 16. And so then I'm asking myself the question, is 0 less than or equal to negative 16? And of course, the answer to that would be no. So that interval is out. Let's see, now I need a number between 2 and 4. And by the way, this is a less than or equal to, so I've got closed dots here. Closed dot here, because it's going to include 2 and 4 in my solution set, no matter how that goes. So let's say, well, let's choose 3. Let's see if I put in 3 for x squared. Well, 3 squared is 9. 2 times 9 is 18. But then negative 10 times 3 is negative 30. And so 18 minus 30 is negative 12. All right, let's see. 2 times 3 is 6. And 6 minus 16 is negative 16. And so I'm asking myself the question, is negative 12, so 12 or 18? 12. Is negative 12, oh, that's 10, isn't it? Less than or equal to negative 10. Well, negative 12 is less than or equal to negative 10, and so that interval is certainly part of my solution set. Well, let's test a number out here past 4. Let's do 5. So let's see, 5 squared is 25, and 2 times 25 is 50. I'm going to write these down. And then negative 10 times 5, that's negative 50. All right, and then 5 times 2 is 10. and negative 16. So then I got 0 is less than or equal to negative 6. And I asked myself the question, is that true? Well, no, that's not true. So that interval cannot be. So somewhere between and including 2 and 4 is my solution set. And so I'm going to write this in interval notation. And I'm going to use a bracket because we're doing a less than or equal to. So I've got my solution set is between and including 2 and 4, including 4. Now let's look at one that's a little bit different. It's talking about end behavior. You know, if I've got a quadratic equation and the coefficient is positive, then I'm going to be arms up. My end behavior is both going out there in the same direction. But let's look at one that might be a little bit different. All right, so here I got 2x cubed plus 7x squared minus 2x minus 45 is greater than or equal to 0. Now I graphed this thing, as you see over here, and it looks a little bit weird. And remember, when I graphed that, I actually set that as y is less than or equal to. Notice how I changed the inequality. I didn't really change it. I got the open end that didn't going in the same direction, 2x cubed plus 7x squared minus 12x minus 45. But you know, it looks like maybe I've got a x-intercept at negative 3. And I could probably use synthetic substitution to work this thing down to a quadratic equation. And of course, I also could go all the factors of 45 over all the factors of 2 using that theorem. But I see that negative 3 sitting out there, so I'm going to test it. So I'm going to say negative 3, I'm going to synthetically divide, and then I got 2 and 7. And negative 12 and negative 45. Let's bring down the 2. So negative 3 times 2 is negative 6. 7 minus 6 is 1. Negative 3 times 1 is negative 3. Negative 12, negative 3 is negative 15. And negative 3 times negative 15 is Shazam, 45. And negative 45 and positive 45 is 0. So yes, in fact, I do have a 0 at negative 3. But you know, it looks like it bounces off that negative 3. It doesn't really cross it. It just hits it and then turns right back around and goes the other way. Well, let's factor this quadratic. So I got a depressed polynomial now that I could write as 2x squared plus 1 minus 15. And I need to factor that. So I'm going to draw 2 sets of parentheses. Well, since I got a coefficient of 2 on the x squared, I know I got to have a 2x and an x. My constant term is negative, which means I got to have a positive and a negative inside my parentheses, but I'm not exactly sure which way to go. And then I've got a positive 1 for the middle term. Let's see. Well, 3 and 5 equals 15. 3 times 5 equals 15. Which should be positive and which should be negative? And I got this 2 out here. Let's try negative 5 and positive 3. Let's see. 2x times 3 is 6x. And negative 5 times x is negative 5x, and 6x minus 5x is 1. Oh, I should have an x right there. 1x. Don't know why I wrote the 1. I should have just written x. I was thinking about that 1, I suppose. Well, let's see. Let's set each factor equal to 0 and see what we come up with. So I got 2x minus 5 equals 0. Let's add 5 to both sides. 2x now equals 5. Divide by 2, and x is equal to 5 halves. And if I look over here to the right, that looks about right, because 5 halves is 2.5, and it looks like we've got an x-intercept right there about 2.5. That looks pretty good. And let's see, well, I got the other factor, which was x plus 3. Let's go x plus 3 equals 0. X, well, shazam, look, that's negative 3 again. So I've got a 0 at negative 3 with a multiplicity of 2. And if I think about it, that would be true because I'm bouncing off that x-axis over here at negative 3. And then from 5/2, it looks like x goes all the way out to infinity. So I'm going to have a union in my solution set. So what would my solution set actually be here? Let's think about this. Well, I've got an x-intercept at 3, negative 3, excuse me, negative 3. And then that is in union with, and let's see, I've got a greater than or equal to, so I've got to have a bracket. I use the braces over here on the left because it bounces off. What 5/2? And then out to infinity. And since it's infinity and never ends, that is a parentheses when I write that in interval notation. That was a bit interesting. Carry on.